Number 5, for each function, give the x value of each discontinuity and classify it as removable. I've spelled removable incorrectly there, my bad. Infinite or jump 4 points each. Okay, so we have this guy, f of x is x squared minus 3x minus 10 over x squared minus 9x plus 20. So for these types of problems, you probably want to factor. So I factor the top and the bottom. I'll let you go over that yourself. Here we see that, well, there's a removable discontinuity at x is equal to 5 because those x minus 5 would cancel. But because of the domain, you still can't say f of 5 is defined. Okay, so at x is 5, there's a removable discontinuity. Okay, and then at x is 4, we see that usually there's a asymptote there, a vertical asymptote. So that's why there's an infinite discontinuity there. As simple as that. Okay, now we have this weird piecewise function over here. Okay, so the strategy here is we got to check where it starts, why the branches are created. So at x is minus 3, there might be some discontinuity there, so we got to check there. And at x is 0, we probably want to check there. Okay, so that's why I said check x is negative 3 first. Okay, so we're going to use the definition of continuity, which says limit as x approaches negative 3 of f of x equals f of negative 3 if it's continuous. Okay, so I found the limit from the left. So limit as x approaches negative 3 from the left of f of x, that's equal to 2. And from the right, it's also equal to 2. Okay, so the limit as x approaches negative 3 is equal to 2, since the limit from the left equals limit from the right. However, f of 3 does not exist. You can see there's no value for f of 3, or x is not defined at. G is not defined at x is, oh, these should all be g's, by the way, my bad. Let me fix that now. Let me fix it over here also. Give me one moment, sorry about that. There's also a G. Okay, let me backtrack. What was that? So I was finding limits, and I just found out that the limit as x approaches negative 3 of g of x is 2. Okay, but g of 3 does not exist, since we don't see there's a value for g at x is negative 3. It completely omitted it. G of 3 does not exist. Definition of continuity is not met, so g is not continuous at x is 3. Negative 3, sorry. It's a removable discontinuity. Why is it removable? Well, if we just add one more line over here, that g of x is equal to 2 at x is negative 3, then it will become continuous again, since that definition of continuity, limit definition of continuity, is met. Okay, so that's why this one is like that. And then we also said we should check x is 0. Okay, so they give us the value for g at x is 0 is negative 2. Okay, so we have part of the conditions for the limit definition of continuity. So let's check the limit now. So as x approaches 0 from the left, it's negative 4. I'll let you go through the math. As x approaches 0 from the right, it's negative 5. So since the limit from the left does not equal limit from the right, limit does not exist. G of 0 is negative 2, as I was saying, and they gave that to us, right? These are for sure not equal. How can a limit does not exist equal negative 2? Impossible, right? So definition of continuity is not met. So G is not continuous at x is 0. Here is a jump discontinuity because here we can see the limits do not exist. I mean, the limits don't match each other from the left and from the right. So it's a jump discontinuity. Okay. Next, this is trying to get us to use the epsilon delta definition of the limit. So it asks us find the limit as x approaches 2 for x plus 2. Then find delta such that absolute value of f of x minus L less than 0.1 whenever absolute value of x minus 2 is between 0 and delta. Okay, so we first find this limit. That's easy. That's 10. We can just plug in x is 2. Okay, now we got to use the epsilon delta definition. Okay, so this is what they gave us. F of x minus L is less than 0.1. So L is the limit, which we found to be 10. Okay, so that's why that's here. F of x is 4x plus 2. So we plug that in over here. Okay. We simplify 4x plus 2 minus 10, that's 4x minus 8. Okay? We can factor out a 4 from both of these. So it becomes 4 times absolute value x minus 2 is less than 0.1. Divide by 4 on both sides, absolute value of x minus 2 is less than 0.025. Okay, so this looks just like this, right? So our delta is 0.025. Simple as that. Okay. Use the limit definition of the derivative to find m tan, which is equal to f prime of x. Then find the equation of the tangent line to the graph of f of x is 2x squared minus 3x minus 1 x is equal to 2. Okay, so this is the limit definition of the derivative. So I wrote that down here, and then I plugged in f of x plus h. So wherever there's an x, plug in x plus h. That's what I did. Minus f of x, so I put in parentheses f of x over here. So minus f of x is here over h. Okay. The whole idea for this is you got to simplify. So I'll let you go through the math. Basically, I expanded this and distributed later. I expanded this by distributing the minus 3. I expanded this by distributing the negative 1. Things would cancel. So then the answer, I'll let you go through the math. You can pause the video if you like. It should be 4x minus 3. That's the derivative. Okay? So f prime of 2 is equal to 4 times 2 minus 3, which is 5. Okay? This is the slope of the tangent line. That's what the derivative is. Okay? So to get the equation of any line, we need a point and a slope. That's a given. We found the slope just now. That's f prime of 2. The point is, so we want tangent line at x is 2, so we need 2 comma f of 2 as the point. What is f of 2? So we just plug in 2 into here to get f of 2. So that's what I showed over here. It's equal to 1. You can go through the math yourself again. So the point is 2 comma 1. Okay, so using point slope form, the equation of the tangent line is y minus 1 is 5 times x minus 2. In slope intercept form, it's y is 5x minus 9. I just distributed the 5 to both terms and then moved the 1 over here. So it becomes 5x minus 9. Okay. Here was a tricky question. There was a very subtle error in this problem that the teacher probably didn't notice, or unless they made the problem very hard and not solvable, or I don't even know, so I'll just explain what's going on here. Okay, so they want you to find a and b so that this function f is continuous for all x, okay? So they give you this piecewise function. So the technique here, whenever they give you something like this, is always we have to take limits from the left and from the right and make them equal to each other in order to satisfy the definition of continuity, the limit definition of continuity. Okay, so the discontinuous points seem to be 1 and 4, so we got to find the limits at those points. So that's what I said. To make f continuous at x is 1, I found the limit from the left and from the right. So from the left, it's just of 2 minus x squared. So that's equal to 1. Okay, from the right, it will be this guy over here. So that's equal to 3 plus a over 1 minus b. We want the limit to exist in order for that definition of continuity to be possible for it to meet the definition of continuity. Can't talk right now. This video is getting a bit long. So we want to set these equal to each other. That is set over here. So we want 1 equal to 3 plus a over 1 minus b. We do pretty much the same thing for x is equal to 4. Okay, so the limit from the left and from the right. And again, we want the limit to exist, so we set the results of the two limits equal to each other. So from the right, it was 0. From the left, it was 12 plus a over 16 minus b. So 0 is equal to 12 plus a over 16 minus b. Okay? So here we can solve for a easily. So 0 is equal to 12 plus a. If I multiply 16 minus b on both sides, this is times 0, that would go away. So a is negative 12. We found a is negative 12. We can plug in negative 12 into this equation to solve for b. So that's what I showed over here. B would equal to 10 then. Okay, so those would be our a and b. But there's a problem because notice, if a is negative 12 and b is 10, there's still a discontinuity. So when b is 10, when x is square root of 10, then there's still a discontinuity. There's asymptote there. What is square root of 10? Square root of 9 is 3, so it'll be a little more than 3, but it'll be less than 4 because square root of 16 is 4. So square root of 10 will be between 3 and 4, which would be this branch, as I was saying. So when x is square root of 10, then we'll be divided by 0. Then that's a discontinuity there. So there's a subtle problem with this question. So there's probably a typo somewhere in the question, unless the teacher wanted you to solve it in a completely different way. Then I didn't do that here. But I'm assuming they wanted you to solve it like how I did, to use the definition, continuity, and all that, like in other problems I've seen. But there's a big problem. There's still a discontinuity, so watch out for that. Okay, number 9 is true, false. It doesn't say you need to explain stuff, but I gave counterexamples and some explanations. Okay. Part A, if f is discontinuous at x is -3, then f of -3 is undefined. This is false, because I can think of a counterexample right away. If f of x is x, but x is not equal to 3, okay? Because if we didn't have this bottom condition and this condition, if f of x is x, then the f would be equal to 3, right? If I put this condition in that x cannot equal to -3, then there'll just be some like hole there. But now I say that x is 3, f is equal to 0. So there'll be technically this kind of removable discontinuity still. You can fill in that hole still, but this just gives you an example that f of 3 is defined, but it's discontinuous at x is 3. Okay, so this is just a counterexample, simple counterexample to prove that statement to be false. B, limit as x approaches -infinity of e to x equal to limit as x approaches infinity of e to x. This is for sure false. If we know how the graph e to x looks, that's for sure false. Because as x approaches -infinity, e to x approaches 0. And as x approaches infinity, e to x approaches infinity. So they're not the same. If x approaches -3 of f of x is equal to 7, then there exists delta greater than 0 such that f of x minus 7 absolute value is less than 0.000001 whenever 0 is less than absolute value x plus 3, which is less than delta. This is true because this is just the delta, the epsilon delta definition of the limit. Okay, they don't give us the f, but they tell us that the limit exists because it is equal to 7. The limit exists. Then for sure there exists some delta such that this is the epsilon. Okay, this is just using the definition, so this is for sure true. Okay, D, g of x is equal to ln of absolute value x minus 2 is continuous on an interval -infinity to infinity. This is for sure false because we can't take the log of 0. So when x is 2, g of x is undefined. Simple debunk right there. If n is odd, then limit as x pushes c from the right, 1 over x minus c to the n is equal to -infinity. This is false, because this is the technique I was showing earlier. It becomes 1 over a small positive number as x pushes c from the right, so it's a little bigger than c. So some number bigger than c minus c, that will be positive. Positive number to the n power, and it doesn't matter if n is odd or even in this case. It will be positive number to some positive power, that would be, or positive or negative power, it would be positive. So it will be 1 over small positive number, which is, so if n is positive, it will be positive infinity. If n is negative, it will be 1 over a big positive number, which is still positive infinity. So I should fix that. It should just be 1 over positive number. Okay? This one, it says if this limit is -5. Okay? And it is. So I showed my work here. The technique here is we're trying to find the horizontal asymptote. So to find that, we factor out the biggest degree of x on top and factor out the biggest degree of x on the bottom. So the biggest degree of x on top is x. So I factored that out. And let's work inside the square root first for the bottom. On the bottom, the biggest degree inside the square root is x squared. So I factored that out. Okay, so a square root of x squared is absolute value of x. Okay, so remember when we take a square root, it's plus or minus. So that's why I put absolute value of x. Now, as x approaches infinity, absolute value of x is x, because x is positive. Okay. Now, the x's would cancel. So we're left with this. Now we can take the limit as x approaches infinity, because 2 over x, that would approach 0. 5 over x squared, that would also approach 0. So we're left with minus 1 over square root of 4, which is minus half, which is what they gave us originally. So true. So I should say true. Okay. And this is a bonus question that this teacher gave. Find the value of a so that the limit exists, then evaluate the limits. Okay, so what I immediately thought was, well, let's try plugging in x is negative 1, as usual. When we get that, we get 5 plus a over 0. So we probably want to make it indeterminate, meaning 0 over 0, for a chance for the limit to exist. Okay? Otherwise, if it's some number that's not 0 over 0, then it's positive or negative infinity. Remember that? So that's why we want it to be indeterminate, 0 over 0, for a chance for the limit to exist. Doesn't mean it would, but there's a chance for it to, okay? Therefore, so let's make 5 plus a is equal to 0, or a is negative 5. The limit becomes this guy then when a is negative 5. I factored the bottom to be like that. Okay, so how do we evaluate this limit now? So I use long division to simplify the inside of the limit. That's what I tried to show here. Okay, so in the interest of time, I won't go through the steps of long division. This is me showing my work over here. So when we do the long division, we get a remainder of 0, and this is the quotient. So the limit simplifies to limit as x approaches negative 1 of 3x squared minus 14x minus 5. That's the quotient, but then we still have this 3x minus 7. So that's why that's still down here. Okay, now this is solvable. If you plug in x is negative 1, we get minus 6 over 5. Okay. And that's this exam. It's kind of long. This is kind of a long video. I didn't break it up into multiple parts, but this is how we solve this exam. Okay, hopefully this has been helpful for any of you that are studying for the exam, for the final or something like that, or you're just watching this for fun. I don't know. Please like and subscribe as always if you found this helpful.